Hello everyone and welcome to another application development with ASP.NET video. Here we are with episode 18 and with our project management system continuing in this video. This will be part 13 of that system. So joining us we have our host, Mr. Nelson Lakay, also Zach Parrish and myself, Jason Busby. And with that, let's go ahead and turn this over to Nelson.
Alright, so over the next few videos we are going to be finishing up the infrastructure that we've been working on so far. What we chose to implement sort of first is the authentication layer, and we're going to be completing that, hopefully, finally. I just want to point out though that applications, generally when you start them, are as hectic as what you've seen already. Generally you have to jump around everywhere because you're implementing the bare minimum of every component. So things have been very disjointed. But
what you're getting at is it's going to begin to smooth out here very soon.
Right. Eventually we will be implementing features in one or more steps in a lot more contained manner than having to jump around and implement a bunch of stuff from scratch. So it's going to be a lot better once we get past this initial hump. Okay. So the first step to getting past that is to have a system where we have users in the system and have them able to log in and be authenticated.
Okay.
So we have the authentication service that we've actually already started implementing. And at this point, the only thing remaining in the authentication service is if the password hash doesn't match, then throw. And we haven't really talked about that yet. We haven't talked about what hashes are, why we store passwords like or using hashes, and how we compare them. So I guess for those of you who don't know what hashes are already, and I suspect that some of you might not, what a hash is it's a function, and there are multiple types of hash functions. Examples would be MD5 or SHA-1. The idea of the function is that it takes in a string input and returns a string output. And the input is always going to be arbitrary. You can pass any string into a hashing function, or any data into a hashing function. It doesn't necessarily have to be a string. And it's going to return something. And the return values of a hash function have some unique properties that we can exploit to store passwords securely without relying on encryption. Encrypting passwords is stupid, and you should not do that. Because unlike credit cards, once you see how this works, you never need to retrieve the data of a password out, and you don't want that to be possible, period. So by making it impossible, we're going to significantly secure the system, because if it were hashed or if it were encrypted, someone could just easily get the decryption key and do whatever they want. So to demonstrate sort of the properties of hashing function, I'm going to go ahead and put the input in these next series of comments. I'm going to have an input, a tab over, arrow, and then the output. And now this is just going to be an arbitrary hash function that isn't actually a hash function. I'm just going to pound on the keyboard. But
yeah, but you're saying that if you were to send A in as your example, then coming out of it would be, and this is just a random example?
Right, would be something.
You'd get this here.
Now, the interesting properties about hashes is that the output will never look anything like the input. The other interesting property about hashes is that separate inputs, no matter how related those separate inputs are, the output should always be considerably, that's not considerably,
neither is that right. You keep starting with L.
There you go.
Considerably different. So it's very difficult to correlate the output with the corresponding input. The next interesting thing about hashes is that given the same output, given the same input, it'll always return the same output. So for example, if we were to give my arbitrary magical hash function an A, it'll always return this. No matter, as many times as you call it, it'll always return that same output. But if you give it anything even slightly different, it'll give you a ridiculously different hash output.
Let me ask you this. Is the number of bytes of the output locked to something?
In all the hash algorithms that I know about, yes. They are going to be fixed.
What happens if you have an input that is bigger in bytes than your output?
That's actually interesting. It'll work just as expected. It's not going to truncate the input at all. It's going to use every single piece of information from the input to generate the output. But what you're suggesting brings up another a potential flaw, but also another potential layer of security, in that multiple inputs could potentially result in the same output.
Yeah, that's what I was getting at. I mean, at some point, it seems like if you can have an input which is larger than your possible output, the data is going to have to wrap back
Yes,
around.
and so theoretically, there are infinite amount of inputs that could be given for a potential output.
Okay.
So yeah, and to actually reverse a hash, it is impossible. What you have to do instead is do a brute force attack, and there have been relatively optimal solutions to reversing hashes in the form of rainbow tables, which are pre-computed key value pairs of inputs and outputs, and they take those outputs and they combine them with inputs to see if they match, and then they figure it out. But of course, like you said, there could be multiple outputs for a given input, so there is a level of error correction in that process.
I see.
But yeah, so they're not foolproof. And what if, for example, two people have the same password, and that happens a lot because there's a lot of people. If you've read about the whole Gawker incident, there's a lot of people who have databases filled with passwords that are things like password and ABC123 and 12345.
So true.
And it's awful. But basically, what that means is that all a potential hacker would have to do if he got a hold of your database was to hash ABC123, compare it against every single record, and then he could have potentially just found multiple accounts that use that same password. So in order to make it impossible for very simple dictionary key value pair brute force attacks, we do what's called salting. And salting basically appends some additional data. So I'm going to say D or J is the salt of this input. And all the salt is it's a string that we somehow create, and then we append it to the input, which will give us a drastic output, even if two users use the same password.
That's because we're wanting to make sure that that string, that at least some of the string that gets added is going to be generated on a individual basis in some unique way?
Yes, the method that we're going to go through in this is we're going to randomly create a salt for each user, and each user will have a salt row in the database. In addition, we will use an arbitrary string in the code itself, just for whatever. I mean, might as well. Computation is cheap.
Okay.
I mean, could you do something like hash their username and use the output of that as a salt on their password?
Yes, we could do that. But instead, I decided against that for the reason of being able to self-contain all password-related fields in a value type called hashed password. And hashed password contains the actual password hash and the password salt.
All right.
Okay, so at this point, we have to check to see if this password matches with this user. Now, if you remember from how this code works, it's going to go ahead and return a user that matches this email address that we passed in. So this user object is not going to be null after the statement because we throw if it's null. And so we want to say if user.validate password, and then negate this, then throw a new exception, and we'll be writing our own exception class here shortly. And then validate password, I'm going to just hit Alt-Enter, Enter, and that's going to go ahead and create a method on my user class that's called validate password. Now, validate password takes in a string password, and what it has to do, what the logic is behind it, it has to go out, use the password, use the salt stored in this hash password value object, then construct a new salt or a new hashed password using the hashing function, and then compare it to the password hash. And that's probably going to be clearer more in code than how I just said it. So at this point, I can go ahead and create the unhashed or toHash temporary, which is just going to do hashed password dot password salt plus an arbitrary string. I don't know, let's throw in some symbols there. It doesn't matter, it's all just going to be stuff. And then plus password. And then we want to use string.format. Okay, so now we have our hash password salt being appended to an arbitrary string found in code, being appended to the password passed in. And now, at this point, we need to hash it. And to hash it, what we can do is instantiate the SHA-1 crypto service provider, which is a member of the .NET framework, and tell it to do its old hashing stuff. But what I'm going to do is I'm going to break that functionality out into a extension to the string object, just because in case we might need it later. It's a very useful utility function that I find myself adding to many of the projects that I work on. So at this point, you might be wondering where in this architecture should that sort of code lie, and that really depends. I mean, architecture is about knowing where things should go, and it's kind of a gray area. But we want this code to be accessible from every single project in this solution. And the only commonality between all these projects is really going to be this honeycomb.base class library. So that's really the most logical place to put it. The next question you have to ask yourself is, does this function in any way reference any other piece of the framework or runtime, or is any way business specific? And the answer is no. It's a very clear-cut, good candidate for a utils-style extensions namespace. So I will have what I'm saying is I'm making this as an extension method inside the base because it exhibits those attributes of not affecting anything in the rest of the project. I will have other extension namespaces for other specific types of extensions, but stuff. And it'll be a string extensions class because it's a class with extension.
Well, just making sure I understand what you're saying. You're saying that you're going to have other extensions that are more specific that are going to be in extension namespaces specific to, say, domain or model query or et cetera,
Yeah,
query model.
I'm just trying to express that I'm making this extensions namespace, but it's only for specific types of extensions, like what you would put in the utils class, not something that you would throw around everywhere. And you want to keep this small. Utils classes are considered bad practice for a reason. Basically, my justification for the existence of this method is it hides some ugliness from the .NET framework itself. So we need to go ahead and instantiate the SHA-1 crypto service provider. And now we need to hash it. And this class has a method called compute hash. And compute hash is interesting because it takes in an array of bytes and it returns an array of bytes. That's an issue because a string isn't an array of bytes. In order to turn a string into an array of bytes, you need to know the type of encoding that string is, and then you need to decode it into an array of bytes. So to do that, I know that in particular the strings in the .NET framework are UTF-8, so I can go ahead and do encoding.utf8.getBytes, and then pass in that. And now at this point, hash bytes is a byte array, and now it's the hashed representation of that. So now I need to re-encode it into UTF-8 so I can return it as a normal string object. And to do that, you just do basically the reverse of getBytes, which is getString. And then hash in hashed bytes, and our toSHA-1 method is complete. So now I can go back into the user class, and I can say password hash equals toHash dot toSHA-1, and now I can just do return password hash plus hashed password dot password hash plus whatever. What did I append it? Equals. There we go. And there we go. It's just slow. So yeah, does that make sense?
So far.
So at this point, our authentication service is more or less complete after I go ahead and pull this guy up into this conditional to make things more cleaner. And at this point, I guess I can go ahead and write an extension or authentication exception. And I'm going to go into my domain and add an exceptions namespace.
And you want to talk a little bit about why you like to go about creating custom exceptions?
Yeah, I find that there are multiple types of validation. There's the kind of validation that you would use data annotations for, and that are more declarative. And there's the kind of validation that is very method specific, where it's Well, this isn't really validation. I don't know what I'm talking about validation. Just that it's closely related with what this is. So if you like to think of it in terms of validations, you can. Basically, this method can no longer continue to, or we're assuming that the caller of this method can no longer continue to execute properly, given the state of the current application, which is that the authentication information is incorrect. There are a lot of debates about the proper use of exceptions, where you draw the line between a return code as a status and an exception. But I'm going to hold for this particular application, I'm going to go with the convention that services are going to always, or more or less always, be void methods, and they're going to just execute. And if they can't execute, they'll throw an exception. And the reason that is so my controllers will look like service1.invoke blah, blah, blah. And then new line, service2.invoke blah, blah, blah. Then next line, service3.invoke blah, blah, blah. That will be wrapped in a try catch. And then the catch will then pull out the proper exceptions and return the proper error message to the user. And I believe that is the sole purpose of a controller, is to sort of marshal the concept of an HTTP request into method invocations on the service, and then either do something at the end of those method calls or return an error to the user. So basically what I'm saying is that by having this layer, this service layer, throw exceptions on error, it allows us to write a lot cleaner controllers.
Okay.
And again, people don't always agree with that. Some people will say that an exception can only be thrown when the application can physically no longer continue to execute. And I don't know. And those are the kind of people that complain about opening up a new stream writer to a non-existent file shouldn't throw an exception. So I don't really care what they say. I'm going to go ahead and make this inherit exception. I'm going to do an alt insert inner to bring in these two constructors. If you don't have resharper, all this is doing is mimicking two of the possible constructors in the exception class, one with a message and one with an inner exception. And all they do is hand their information back into the exception. And if you're wondering why I'm not using generic exceptions instead of, because I'm actually going to be implementing different types of domain-specific exceptions for a large majority of the different things that can be thrown in the domain. It's just that so our controller code can catch against these specific exceptions. So the controller is not going to catch things like invalid argument exception or null reference exception, or things that are exceptions that are thrown based off of bugs in the code, essentially is what I'm saying. We don't want the controller to accidentally intercept a bug and then swallow it and return a generic error message to the user. We want to only catch specific domain exceptions that we know that we're the only ones that are going to be throwing. And then we're going to let all those system exceptions, all those bug exceptions through, which are going to in turn cause the ASP.NET MVC error handling to be invoked, and we're going to latch onto that with code that will send emails and stuff like that with bug reports. Okay. So that's the reason why I'm creating custom exception classes. So yeah, that's actually pretty much it as far as the authentication service. It does everything it needs to do. We can log in as a user and we can log out. And I'm going to make another method called login as. And all login as is going to do that. And actually, hold on. What I'm going to do here is I don't know why I made a setter there. I have no idea what possessed me to write a setter. And the reason is I can delete that setter, and instead of logged user, I can just use logged user value dot value equals, and then logged user value dot remove, and logged user value dot value equals ID. So now we have a login as method that will allow our controllers to log in as an arbitrary user if we ever need to do that.
Okay.
So yeah. that's more or less that for the authentication service. We also need to go ahead and create a user service for instantiating users and deleting users and updating users and all that stuff. And I think that's more or less the next logical thing to do.
Yeah, I agree. And with that, aren't we going to have to handle the interesting situation of we need an administrator, an admin person in there? Well, we need somebody that's going to be an admin that can add other people.
Right.
So, okay, I'll just let you continue forward.
Well, we need to create the user service that will be invoked by a special controller method that will only be accessible if there aren't any admin users in the system.
Right, right. I mean, because we're starting out with an empty table.
Exactly.
Yeah, that's all I'm saying.
Yeah, we are eventually going to have this console go ahead and do that stuff, but I decided to leave this initial stuff for the console later because I have some really fun stuff I want to do in the console, but we don't have time at the moment to do that. So instead, I'm going to write a route that's only going to be accessible if there aren't any admin users in the system, and then you're going to go ahead and be allowed to create an admin user.
Okay, good. That's what I was getting at.
And the user service is pretty much just going to be create user. And we need to go ahead and pull in our iEntity unit of work provider so we can go ahead and work with our entities. And I can go ahead and just do public void create user, and he'll have a GUID ID, a user type, which we haven't implemented yet. And we need to be able to, yeah, maybe this was what you were trying to say, but I completely missed that.
Ignored him.
Yeah, I do that sometimes.
I get ignored from Nelson all the time. What are you talking about?
We're going to go ahead and have to be able to distinguish a normal user from an admin user. And
Right.
I'm going to do that by a user type property. The user type property is simply going to be an enumeration in the value object's namespace. So that's pretty straightforward. So user type is now working. So in my user service, user type, email address, string, password. Okay, so what's this code going to do? We're going to actually run in to a roadblock here in a second. The roadblock is that we can go ahead and create a new user, but he doesn't have a constructor. He has a default constructor. The next problem is all of these properties are private sets. We cannot set any of these properties publicly, and that was a design decision. We don't want anybody but the user to be responsible for handling his members. So the obvious object-oriented way to do this would be by just implementing a constructor. So I'm going to implement a constructor with everything but hash password. And then I'm going to take in a string password. And then I'm going to write a method that will hash my password for me. So I'm going to go ahead and write a public void update password, string password. Now at this point, this code right here is pretty much redundant. I'm going to go ahead and have to pull that out. And so to pull it out, I'm just going to select this code, Control-Shift-R extract method, get password hash, and there we go.
Nice.
And then actually now I can condense this into a single line, which will look a lot nicer. Because now it's just a method call. Mm-hmm. So now that looks a lot cleaner, and now I can hash a password for multiple points in the same code. So basically all I have to do is say hashed password equals new hash password. Whoa, wrong curly. And I need to fill them in. So I need to fill them in with the salt and the hash. And the salt I'm going to generate up here. And the salt is simply going to be a new random number. And of course in .NET, to do a random number, we need to have a random class. No, not a read them.
I thought it was an impressive name, but
I accidentally pasted it into that. Next, and then toString, and that's going to be our salt. Now we have a problem with the code that I just extracted, because I can set the password salt to salt, but to set the password hash, I need to get password hash. Unfortunately, get password hash.
You did password salt again.
No, I didn't. See?
Yeah, I didn't see anything.
This is actually a problem. We're referencing password salt right there. So what I'm going to do is hit Control-Shift-R and then hit the P key. And then boom. And now I'm going to pass in our new salt into there. And now this guy can be made static, which Restarper is politely telling us. Okay, so there's our user class, with the exception of update password should pass in password. Now we have another problem. And this problem has to do with how we're loading this class. And the issue is that this class is going to be instantiated in one of two scenarios. Either we're creating a new user, which is how we would use this constructor properly, or we are instantiating a user class to be filled in with data from the database by Hibernate. And unfortunately, in Hibernate, there are weird, bizarre, plugin-y ways to get it to register with certain types of constructors. But instead, we're going to opt for the most simplest solution, and that is to provide an empty, public, parameterless constructor. This will make it so Hibernate is happy. If we did not have that in there, Hibernate would throw saying there's a user object, but he has a constructor that I don't know how to invoke.
Okay.
And then also, if you're wondering, Hibernate is not inhibited by the private setters. It uses reflection to set these properties directly. So.
Gotcha. Okay.
So yeah. So now we can go ahead and create a user by just doing this, and then do transaction.store, which I'm going to be fixing here in a second. And I'm not going to fix that just yet because we have another problem. We want email address to be unique. Unfortunately, email address does not have a unique constraint in any way, either on the database or on Hibernate. And instead of coding that in, I think the simplest solution would be to handle that in code inside this transaction, where we're simply going to check to see if a user exists, or if a user exists with this email address. And to do that, I'm going to go. What I could do is do if trans query user any. I have to bring in link. So this will bring in system.link at the top. Email address equals, or email address dot value equals address dot value. And I could do that. But the issue is now we're starting to repeat code. And that's not a whole lot of code that we're going to be repeating, but we can't pretend that this is the most advanced query we're going to be doing against users. We are going to have some queries happening in our domain layer that we need to be able to access in multiple locations, or potentially be able to access in multiple locations. Also, we don't want the code to look at this because this really clutters the intent of the method, which is called create user, and here we are querying against users. So to fix that, we can introduce an awesome layer of abstraction called repositories. And I'm going to go ahead and just make another namespace and create a users repository. And all the users repository is going to do is he's going to have a constructor with the entity unit of work provider interface, entities. And then he's going to have a method called public user get user by email, email address, return entities query or begin trans query user first or default user email address value equals address value. Okay, hopefully that code is pretty straightforward. Now that we have a users repository, we can go ahead into our authentication service and add that as a dependency, and then replace this code with user equals users dot get user by email, and instantly this method already looks a lot nicer. I mean, I think,
I agree.
Yeah, it does. Yeah.
and so does this, by the way, because now we can just we can pull in our users repository, and we can say if users dot get user by email address does not equal null, then we need to throw. And we're going to be throwing a new duplicate key entry, which we haven't implemented yet. Or a new duplicate key, or new duplicate entity exception, which we're about to create. And it's not a folder. It's a class. I don't know, I did that twice. It's going to be a duplicate entity exception. And I'm going to give him the exact same treatment as the other guy. He's going to inherit from exception, and he's going to implement these two.
Am I seeing that wrong, or does entity have like a whole bunch of T's in it and I's and?
Maybe, yeah.
Well, I don't know what that crashing sound was, but something just crashed pretty good.
Yeah.
Entity. Is that how you Zach?
Yeah. Yeah, it looks good.
Yeah, Nelson, hang on 1 second. We're going to pause for just a second, so if you just want to hold the mouse right there, we need to find out what just exploded over here. So 1 second, we'll be right back. Okay, Nelson, it's back, and we were not able to find out what exploded, but something did.
I didn't see any blood. I think we'll be all right.
Yeah. Okay.
Yeah, and
continue.
while we're paused, I did just notice that I messed up the naming of authentication exceptions as well. This should be authentication exception. So I'm just going to hit Control-RR, nuke that guy, and hit Enter.
Nice.
Okay, so
You're working. Did you do everything you needed to in the duplicate? Oh, okay.
so now I need to actually throw a duplicate exception right here. Duplicate entity. I'm going to get this wrong for the rest of my...
There you go.
And then the message is going to be duplicate user, duplicate email found. Okay. I'm going to do two things, actually. I'm going to go into my authentication service, and I just realized I don't think I actually typed in a message for my authentication service, my authentication exception. And by the looks of it, I'm actually referencing an authentication exception from the .NET framework itself. I'm not referencing my authentication exception.
Nicely done.
So what I'm going to do is I'm going to nuke this using right here that's responsible for bringing that class in. And then now ReSharper's going to come and tell me, now that I've corrected the name, it's going to give me an option of which one I want to import. And I'm going to import the domain one. And now I get the error that I expect, which is a message that I have to put in. And I'm going to say invalid email address or password. No period. And just a quick note on messages is these messages, you should write them as if they are going to be displayed to the user. At least in the way I've chosen to use these sort of exceptions. If you need to insert debugging information for later that's not going to be presented by the user, we have an entire class here that we can fill up with properties full of debugging information. So just keep the message something that we can pass to the user, and with that knowledge, we will be able to write much cleaner controllers that don't have to reiterate a message that should already be provided by the domain.
Okay.
So in our user service, we now have duplicate email found. This actually introduces another subtle bug that I didn't quite fully understand until I wrote code like this, and I just realized that through all of the abstractions, we've introduced a subtle bug that will throw on us. And the bug is we're inside a transaction right here. If we go into our get users by email method, I don't know where that came from. If we open up our get users by email method, we see that we're opening another transaction right here. This is a problem. And Hibernate, or specifically ADO.NET, will actually throw on that. So to fix it, we need to go into our service for that, which is under somewhere. I think I passed it. There we go.
So being a bit more specific, so you're saying in one transaction, then we begin a new transaction, and that's what's going to throw.
Right. The way the code is going to flow is that in our user service, we begin a transaction right here with entities.begin, which invokes this
Correct.
code. Then it goes out into the user's repository service and opens up another transaction, which is going to invoke this exact same code again. We want to essentially short circuit that code to where we can just say, if there's already a transaction running, we're running an nested transaction, just return out. So we don't have to worry about that sort of thing. And this is kind of dangerous. I'm sure there's a lot of ADO.NET stored proc fanatics out there who are cringing right now. But it works well with the abstractions that we've chosen, as long as we follow them as in the way that they've been intended to be used. And that is so far just inside either the domain service or the query service, although the query service is not going to have nested transactions ever, because it's never going to be setting anything and querying something at the same time. It's always just going to be returning something. So to do that, we need to find a way to, in the context of a request, and remember, a request is a concept that I want to build into this project from the beginning. And you normally see request as not part of the architecture of certain domains because people want to make them agnostic to request, because not every single execution environment runs inside of a request. I decided that I might as well put the concept of a request inside of the domain, and the reason is, or inside of the system, and even at the service layer. And the reason is because right now, if we were to create a static method or a static variable for is transaction running, and then just use a Boolean or something and set it to true when we're in a transaction, set it to false when we're outside of a transaction, we'll run into a big issue. And the big issue is that this code is going to be executed potentially simultaneously from different requests. So we need a way to hook into a data storage or data structure that lets us associate data to a particular ASP.NET or arbitrary or non-ASP.NET request, and we need to leverage that data structure in a way that makes sense.
Okay.
So yeah, we are going to actually continue on. Remember, in the authentication service, we have this iScoped value abstraction that we started writing.
Mm-hmm.
We're going to extend this to request values as well. And I'm going to write the code that consumes it first for this entity unit work provider, and then I'm going to write the code that will actually make it work. So the code that consumes this would look something like this. It would be private, read-only, static, iScoped value, and then it would be something. And that something is, I want to have a entity unit of work stored there, because I just want to pass in whatever was instantiated here into this method directly if it were called again. So I'm going to have an iScoped value of entity unit of work, and I'm going to call him current unit of work, and I'm going to assign him to, and again, this is a method that this is a class that doesn't exist. Request scope dot create, pass in a lambda or an expression specifically that points to that. And then how it would work is that we would have current unit of work. We would say if current unit of work has a value, then return the unit of work delegate with current unit of work dot value. When we start a transaction, we want to go ahead and instantiate this unit of work, and I'm going to hit Control-Shift-R-V to bring it out into a variable, and then I'm going to set it to current unit of work dot value equals unit of work. Unchecked. And then he's going to work as normal, and then in a finally block, I'm going to write current unit of work dot remove. So the logic is really quite straightforward. We are, at the beginning of the transaction, we are setting the current unit of work to this object that we've instantiated. And then every subsequent time that this method is invoked, before this transaction is completed, we will be just short-circuiting right here.
Right.
Mm-hmm.
Okay. And, well, yeah, we now have to implement request scope.
Right.
And request scope, we're going to implement it the same way that we implemented the other guy, session scope. And it's going to be ugly and nasty, and I hate it, but we're going to...
Okay, then.
There's going to be a better way to do this, but for right now, we're just going to copy and paste this code because we don't...
Nelson, that's horrible.
Oh, real? Wow, you're making redundant code?
I am. And it is horrible, and I'm ashamed of myself.
I mean, even I know that... Well, never mind.
What are you talking about? You probably copy-paste code all the time.
Yeah, from Google.
Seriously. Why write it when you can get somebody else to write it?
That's not a...
We're just trying to give you a hard time, Nelson.
Just
It's all
setting
good.
you up, man. Come on.
Okay, so what I'm doing is I'm going through and I'm adding all the using statements that I need to get this code to work in the first place. And then I'm going to return a new request scope value, which I renamed. And I'm going to change the static constructor to request scope. And then I need to write a iRequestScope service, which is going to be in the abstract folder. And the iRequestScope service is going to look exactly like the iSessionScope service, verbatim. So instead what I'm going to do is I'm going to yank the implementation out of iSessionScope service and just write an iScope service and put the code in there. And then I'm going to use interface inheritance, which isn't quite like implementing an interface and it isn't quite like inheriting a class. But you can think of it like either of those things, where we're basically declaring that whoever implements iRequestScope service must also implement iScope service. But it doesn't, I don't know, we have to do it.
No, that's good enough.
Yeah, it makes sense.
It's whoever's going to consume that interface, implement that interface, also has to implement the interfaces that it inherits as well, even though it's not.
But if
true
somebody
inheritance.
was just implementing the second interface, they wouldn't necessarily have to implement the first one.
Okay, so there's that code, and that should all work. The only problem is we don't have a corresponding implementation of this interface for the web.
I can't believe Nelson just left all of that code that ReSharper was talking about taking out.
Did we already talk about this? I think we... This is a particular instance where I disagree with ReSharper. The reason I disagree with ReSharper is if I didn't have this redundant code in there, it would look like this is a private variable inside the current class, when in fact it's a private variable inside of its parent class. So I personally will always leave static references to private variables of parent classes as explicit as possible, just to make it more, well, explicit, even though it is technically redundant code.
That's cool. We talked about this on a video that was not kept, and I was just trying to push you into explaining that instead of us flying by just in case someone else saw it and goes, wow, Nelson always gets upset if people leaves redundant code.
No, I always do, because 99% of the time redundant code leads to clutter. In this case,
yeah, exactly. But basically I was just trying to get you on video explaining why that was being left.
Okay, so now we are going to implement the web request scope service, and all that he's going to do, web request scope service, is going to implement the iRequest scope service. To the same effect that the web session scope service works. And the web session scope service, and we've already gone over the implementation of this, but he uses the HTTP context.current.session data structure, which is used for, well, storing session values. There's another thing that isn't as well known, I suppose, but is immensely useful, and he's called the items. And items are a key value collection that can be used to organize and share data between... Actually, this is probably the part of the documentation that will confuse people, because this has nothing to do with iHTTP modules or iHTTP handlers. Well, it kind of does, but it serves an auxiliary purpose. And the auxiliary purpose is this is a collection that is going to be instantiated for every request, and it's always going to be unique to the current request being executed. So we can use it to store the exact type of data that we're storing here. So I'm going to basically, because the implementations are going to be verbatim, again, I'm going to copy paste. I'm going to bring in system.web, and then I'm going to change current.session to current.items. And there we go. So now we have our web request scope service, and finally we need to do our poor man's dependency injection up here by saying request scope dot set scope service new request or new web request scope service. And if we were doing a testing project, or if we were doing a console application or any other kind of application, we would be providing different implementations of these classes. So yeah, that will allow us to finally go back into our iEntity unit of work provider. And again, I apologize for jumping around so much, but it's difficult to write something like this in a serial fashion when there's so much jumping around you have to do.
Mm-hmm. That makes sense.
So request scope now works, and it'll now function as expected. So that basically will fix the issue in our users class, or our user service, sorry. But there is another issue that I kind of ignored. I mentioned, but I ignored it. The issue is the particular way that I configured on Hibernate was more or less incorrect for how I was going to use it. And that was just a typo on my part. And, well, a few typos. The first typo is that in our unit of work provider factory, and remember this is the thing that instantiates the session factory, we go ahead and do our AutoMappers implemented elsewhere in the code, right here. So AutoMapper is under our Honeycomb Services Mapping AutoMapper. And in our configuration, we say when our ID type is of GUID, then use the GUID generator. And unfortunately, what this does is this actually instructs Hibernate to be responsible for the GUID generation, which we don't want. We want to be able to do, in the controller, create a new GUID and then operate on that user without having to rely on any return parameters passed by the service layer, because we want to keep the service layer more or less 100% void, so that the code executed in the controller is as clean and straightforward as possible. The second you start putting return values in those service calls, everything gets complicated in the controller layer.
So the bottom line is we want to assign our own GUI that we've got.
And to do that, instead of doing assigned by GUID, we want to do assigned by, or generated by GUID, we want to do generated by assigned. Now we want to keep the integer as identity, just a side note. Integers are going to be used for entities under an aggregate that aren't aggregate roots, which should only ever be referenced by aggregate roots themselves, meaning that they can do all the stuff that they want to. We're not going to be instantiating them directly in the controllers anyway. So now that we've done that, the second issue is, now that we're using assigned, there's a subtle performance issue with this. And the subtle performance issue with this is that ultimately, at the implementation level of this entity unit of work provider, we have a store which does save or update. And save or update is really convenient because it'll see if an object needs to be updated or if it needs to be saved. The unfortunate thing is save or update doesn't work well, it does work, but it does work with a performance penalty when you're working with the assigned generator. Basically, Hibernate has no way to identify if an entity has already been stored in a database or not without having to actually look at the database first. So a save or update on an entity with an assigned generator will always have a small, or well, actually it's twice the amount of SQL generated, so a fairly large performance implication. To fix that, we're going to have to directly specify if we want to save or update our entities, and that involves changing our interface a little bit. And this is the interface defined in our Honeycomb Base Services Abstract namespace under iEntity Unit of Work. So basically what we're going to be doing is taking store And I'm just going to do a Control RR and do a save. So I just rename store to save, and then I'm going to create another method called update. And you see that now trans.save, because save is what we want, we're creating a new object. And then our entity unit of work now needs another member implemented, which I just did. Update just popped in, which we now need to implement. So it's going to be session.update entity, return entity, and this saver update is going to turn into a save. So now we will always be telling in Hibernate if an object either already exists in the database and it needs to execute a SQL update, or if it doesn't already exist in the database and it needs to execute a SQL insert. So yeah, that's actually almost about it until we get to the UI. The last thing that we should do is go ahead and fix our AutoMappers to, fix our entity unit of work provider factory with the right namespaces. And we're also going to have to add the query model for our user, just a really basic one. So I'm going to leave this file open because we're going to be editing. No, not that file. I'm going to leave this file open because we're going to be editing him in a second. And then I'm also going to start working on our query model, which is just going to be really quick. It's going to pretty much follow the exact same convention of our other project. We'll have a model folder, a user aggregate, or a users, and a user class. And the user class, now that we finally have some code in here, it's going to be easier to see what I mean, or what the entire point of building out the query model is. And that's this query model is going to be void of all functionality. And he's going to be called user DTO. Sorry about that. So this user DTO is going to be devoid of all functionality. He does not come with the baggage of this domain object, which is precisely what we want. And then we need to say use table name of to instruct the AutoMapper to use the type of the user object for the same table name. So we line up our table names, which we've already discussed. So that is the extent of our query model. Finally, we just need to implement a repository that we can use to query against users. And I'm not going to call it a users repository. And the reason why I'm not going to call it user repository is we already have users repositories. And that's sort of the frustrating thing about the whole DDD thing, is that they talk about repositories and factories and stuff, but a repository and a factory in the context of DDD is a very specialized version of what the repository and factory patterns are. And so when we try to use the correct terminology in our domain, like repositories, we end up with conflicts when we start trying to use repositories in a more general sense. And so what I'm going to do is I'm going to have a repositories namespace, repositories, not repository. And he's going to have classes that are suffixed with queries. So this is going to be called user queries. And I think not only does this avoid potential conflict with our users repositories or users repository class, but it also pretty well specifies what exactly this class is going to do. And all he's going to do is talk to and hibernate to pull out DTOs and return them out. And like I mentioned before, we're going to have functionality that says if there's an admin present, then we want to allow a special route to allow an unauthenticated user to add an admin. So I'm going to write a public bool is or does admin exist, and he's going to go out and return entities begin. We're going to query over our user DTO. With any, we're going to bring in system.link, and then user type is admin. And then I'm going to reduce this redundant code and bring in another using statement. So yeah, that's our first query that we're going to be using down the line. And finally, we have to come in here and we have to add the namespaces of everything we want to automap. So in the domain, we changed things up. We added the model namespace. So it's now honeycomb domain model users, and in our query model, it's now query model.model.users. And both of these namespaces need to be automapped. And the final thing to get this working, and we're probably not going to compile in this video, but in the next video when we actually go ahead and start writing the markup, we will. The final thing is setting up Autofac. And this is an internal struggle I sort of had with myself, is do I want to put the Autofac configuration of the domain and of the query model, do I want to provide a templated configuration for Autofac in those? And remember, what I mean by templated configuration is a default sane configuration that we could choose to ignore if we wanted to do anything special with Autofac, but we generally won't need to. So it would be sane to provide a class in here, an Autofac module that wired up all these classes that we need to be able to use inside of Autofac's container. And I could put that somewhere else. I could put that in the services, for example. But I kind of wanted to leave those configuration classes as close to the classes that they map as possible. So I decided just to opt out to add a reference to Autofac from the domain and the query model, and provide a module implementation in both of those classes, or both those class libraries. So I'm adding a reference to Autofac. I'm going to go ahead and create an domain module who's going to inherit Autofac.module, and who's going to provide a custom load method that's going to go ahead and configure all of our objects. So we're going to go ahead and register our user's repository as self and in single instance, or as single instance, sorry, or single instance. It is kind of inconsistent between the different kinds of scopes you can register things in. And then I'm going to register type authentication service. As self, single instance, and then I'm going to go ahead and register type our user service as self, single instance. And then I'm going to remove that using statement. Alright, so there's our domain module. And I'm going to use this as an opportunity to delete these token interfaces. I'm just going to latch onto that class. So in our query model, we're going to have a query model module.
Close.
Query module. Query model module. And he's going to inherit from Autofac module, so we need a reference to him. And then he's going to do module, and then I'm going to hit Control Insert O load space enter, and then do builder register type user queries as self single instance. Okay, and finally we can go ahead into our .web, come down here and say builder register module domain module builder register module query model module, and now all of our services are provided by Autofac to the rest of our application. The final thing is this services will no longer build. The reason we'll no longer build is that these guys no longer exist, or at least one of them doesn't. Let me kill the other guy. Here you are. Goodbye. And I'm going to say domain module and query model module, and just there. That's fine. Those classes will never be removed. and it's easier than dealing with other stuff. So, yeah.
Nice. Very nice job.
Nice work.
I mean, 1 hour on the dot. You've been rocking.
Yeah, I know we went through really quickly. There were a few discussions about random design things that I hope were interesting, and hopefully in the next video or two we will actually be implementing features finally, and we'll have, like I said, basically we've been just getting the structure in place. We have our projects here, we have our things configured, and we have sort of a template to go by for our future types of objects like services and repositories and queries. So yeah.
Yeah, very nice. Okay, well, with that, Nelson, thank you very much, sir. And that will wrap up this video, and we'll catch you guys in the next. Once again, thanks a lot.